problems in root locus stability analysis, right? So here a unity feedback control system whose open loop transfer function g of s equal to k divided by s into s squared plus 4s plus 13. For this open loop transfer function, we need to sketch the root locus. So before we are going to the root locus, guys, please do follow the procedure, right? So this is the procedure for constructing root locus. So you can go through it. I'll explain it step by step, right? So step number one is to locate the poles and zeros on the s plane, and root locus branch always starts from open loop poles and terminates at zeros, right? So this is step number one. So I'll do parallel, right? So step number one is to find the open loop poles and zeros, right? So I'll do step by step so that it is easy for you to make the things clear, right? So step number one in root locus is to plot or find the open loop poles and open loop zeros, right? So open loop poles and open loop zeros. So you know how to find out the open loop poles and open loop zeros, I think so, right? So if you want to find out the open loop poles, what you'll do, you will equate the denominator term equal to 0, right? So for pole finding, you have to equate denominator term equal to 0. Here the denominator is s into s square plus 4s plus 13 equal to 0, right? So here either I can equate s equal to 0, or I can equate s square plus 4s plus 13 equal to 0, right? So here s equal to 0 is one pole, right? So another pole, if you are solving this equation in the calculator, the value could be s equal to minus 2 plus or minus j 3. So this is the another pole. That means here how many poles are there? So there are three poles. So one pole is P1, P1 equal to 0. So another pole is P2, P2 equal to what? Minus 2 plus J3, minus 2 plus J3. So what is the third pole? The another third pole is minus 2 minus J3. So these are all the three poles of the given transfer function, given open loop transfer function. Now let me find out the zeros, right? So here if you want to find out the zeros, you have to equate numerator equal to 0, right? So if you are equating numerator equal to 0, do you find any pole? Obviously no, right? So we are equating numerator equal to k equal to 0, but it is impossible to k become 0, right? So k is not equal to 0, so there is no zeros. So there is no zeros. So for this problem, three open loop poles are there and no zeros are there. So three open loop poles and no zeros. So that is what the condition, right? So that is the step number one. So step number one is what? Step number two is to determine the root locus and real axis. So you have to determine the root locus branch. So here, if you want to find the root locus branch, you have to take a test point and the real axis. So if the total number of poles and zeros combinedly on the real axis to the right of this test point is odd number, then the test point is lies on the root locus branch. If it is even number, then the test point does not lie on the root locus, right? So now that also I'll tell you, right? Now before that, let me draw the diagram. I mean, or simple diagram. Let me draw it in S plane. Okay, so that I am doing here. For the sake of convenience, let me take one more thing, right? So here, this is our S plane, right? So in S plane, so you can use I mean, scale pencil and everything, but as of now, let me use this, right? Okay, fine. Okay, so this is our thing. Now let me extend it. So now, what are the values, right? So here, this is our S plane. So this is our j omega axis, that is imaginary axis, and this is sigma axis. So here the value is positive. Here the value could be negative. In j omega axis, the value is positive. Here the value could be negative. Here the value could be negative. So now at this juncture, this is 0, right? So now tell me what are the poles? What are the poles? Pole 1 is 0. So 0 is here, right? So pole 1 is 0, right? So this is the first pole. So pole is marked with the cross symbol. Pole is 0, right? So what is the second pole? Minus 2 plus J3, right? So here this could be a minus 1 and this could be minus 2 and this could be minus 3, right? See, simply I'm drawing, right? So, and this is also 1, 2, and 3, right? Similarly, here this value could be minus 1, minus 2, and minus 3. This value could be plus 1, plus 2, and plus 3, and this is 0, right? So always if you want to mark the pole, you have to use the cross symbol, right? So these are all you can put a dot. That is the best way, best practice. Okay, fine. So the first pole is 0. So what is the second pole? It is minus 2 plus j3. So what is minus 2 plus j3? Minus 2 is there, plus j3, right? So 3 is there. So these are intersecting at this point. So you have to put that. This is our pole 2. And minus 2 minus j3 is also there. So this is our pole 3, p3. And this is our p1. Right? So in the first, now we have to find out the root locus branch. Right? So here, if you want to find the root locus branch, right? So the second step is to choose the right. Step 2 is to find the root locus branch. Find the root locus branch. So for that, you have to check it out how many poles at the real axis. Find the root locus axis or root locus branch, right? So now, if I am considering, if I am considering any pole, right? So if I am considering any point, right? So if I am considering any point and the left side, right? So left side of the particular pole, if how many number of poles at the right hand side of this particular test point, this is test point T, right? So with respect to this particular point, how many number of poles are lying at the real axis? Obviously one is odd number or even number, odd number, right? If it is odd number means then there is a root locus branch is existing, right? So tell me where the root locus branch starts and where the root locus branch end, right? So always the root locus branch starts at open loop poles, right? So here the poles and ends with 0, but here unfortunately for this problem 0 is not there, so it may terminate with the point minus infinity. So the root locus branch will be like this. So this is our root locus branch starting and ending point. So this is what the second step indicates. So root locus branch, right? So here, so branch, root locus branch starts from pole at, that means p1 equal to 0, and terminates at infinity. Zeros at, here there is no 0, so zeros may be at infinity, right? So this is what the second step. Now we'll go for third step. So rule number 3. So you have to determine the asymptotes of root locus branches and meeting point of asymptotes with the real axis. So here the step number 3 is to find the asymptotes, right? So step number 3 is purely related to asymptotes. So before we are going to asymptotes, we need to find out the number of branches also, right? So how many number of branches is that? Number of branches also we have to find it out. Number of branches is nothing but whether the number of poles are greater or number of zeros are greater. With respect to that only number of branches is defined. So maximum of number of poles are number of zeros. So here number of poles is what? Number of poles is 3. So maximum of 3 comma number of zeros is 0. So what is maximum of 3 comma 0? 3. So how many number of branches is there? 3. So whatever the number of branches there, same number of asymptotes are available. So number of asymptotes are also, number of asymptotes are also 3, right? So now this is what, now after finding the number of asymptotes, you have to find out two things. One is centroid, right? Or the asymptote where it touches with the real axis, that one you have to find it out, right? So for that we have a formula, right? So that formula only here. So here, after finding the asymptotes of the root locus branches, we have to find out the centroid. So meeting point of asymptotes with the real axis. That is sum of poles minus sum of zeros divided by n. N means number of poles. N means number of poles. M means number of zeros, right? So this is what the formula. Now I have to apply that formula over here. So now centroid is C. Centroid C equal to sum of poles, right? So sum of poles minus sum of zeros divided by number of poles. I am giving some notation for number of poles. Let me give us n. And number of zeros. Let me give some notation called m. Okay, so this is how I had to go for it. So how many sum of poles? So what are the poles? The pole is 0 and another one pole is minus 2 plus j3 minus 2 plus j3. So minus 2 plus j3. Another one pole is minus 2 minus j3 minus 2 minus j3, right? So these are all the poles. There is no 0, so these are all the sum of poles. And since there is no 0, so I can put as 0. And how many number of poles? 3. How many number of zeros? 0. So 3 minus 3, 0, right? 3. So minus 2 plus j3. So here after this, which term will be getting cancelled out? Here this j3 and this minus j3, both the things get cancelled out. Here we have minus 4 divided by 3. So what is the answer? Minus 4 divided by 3. So minus 1.33. So this is the centroid point of the asymptotes, right? Next, after finding the centroid of the asymptotes, we have to find the angle of asymptotes. That is very easy, right? So where we have to draw the asymptotes. I mean, which angle we have to draw the asymptotes. That is also matters, right? So if you want to find the angle of asymptotes, you can use this formula. That is plus or minus 180 degree into 2q plus 1 divided by n minus m. So n is the number of poles, m is the number of zeros, right? So now I'll use this formula over here, right? So now the angle of asymptotes, the formula could be pi equal to, I can use 180 degree into 2q plus 1 divided by n minus m. So here q could be either 0, 1 or 2. So now let me assume q equal to 0. So let me find out what is the value of pi. So for q equal to 0, the pi could be 180 degree into 2 into 0 is 0. So 0 plus 1 divided by n is number of poles. So 3, number of zeros 0. So 180 degree into 1 divided by 3. So what is the answer? So answer is 60 degree. So likewise you have to find out the values. Now next we will try to find out for q equal to 1. So if q equal to 1, what is the answer? So the pi value equal to what? 180 degree into, so 2 into 1. So 2 into 1 is 2. So 2 plus 1 divided by 3. 3 minus 3 is 0 is 3. So 180 into 3, that is 540. So 540 degree divided by 3. So the answer is 180 degree, right? So this is the second one. Next we will find it out for q equal to 2. So for q equal to 2, the value could be pi equal to 180 degree into 2 into 2. 2 into 2 is 4. So 4 plus 1 divided by 3. So 180 degree divided by 3. So 180 by 3 is 60. So 60 degree into 5. So the answer is 300. Now after this, let me put it like this and I will find the values here or here. So now when q value equal to 4, what is the phase? Phase pi equal to 180 degree into 180 degree into, right? So q equal to 4, right? 180 degree into 2 into 4. 2 into 4 is 8. 8 plus 1 divided by 3 minus 0 is 3. So 180 by 3 is 60. So 60 degree into 9. What is 60 degree into 9? The answer is 450. See, remember guys, this 450 degree, if you want to plot the point 450 degree, you have to complete one revolution in a circle. In addition, you have to travel 90 degrees. So can I simply put that is a 90 degree? Sorry, 60, wait a minute, 60 into, I think I made some mistake, right? So q equal to 3. It is for q equal to 4. So for q equal to 4, so this q equal to 3 means 2 into 3 is 6, right? So 6 plus 1 what? 6 plus 1 is 7. So 60 degree into 7. Sorry, 60 degree into 7. The answer is what? 420. So 420 means that is equivalent to which one? 420 is equivalent to which one? That is obviously it is equivalent to 60 degree. So if you want to uh, mark a point with 420 degree, you have to complete a revolution of one circle with 360 degree. In addition, you have to travel 60 degree. So when q equal to 3, the angle is again 60 degree. Similarly, for q equal to 4, the angle, if you want, you can check it out, the angle could be 180 degree. And similarly, for q equal to 5, the angle could be 300 only. So it is no need to find out the angle for q equal to 3, 4, 5. So it is enough. We have to find out the first three angles, right? So that is what. Right. So now, after finding this, you will try to plot those points in the graph, right? So this is our graph, right? So now, what is a centroid? Centroid is nothing but the central point of your asymptotes, right? Minus 1.33, where that point will be, where that point could be, that point may be minus 1 and minus 3. So can I assume here minus 1.33? This is the point. From this point, you have to mark the asymptotes, right? So now tell me where the asymptotes, what is the first angle? Q equal to, what is the angle? 60 degree, 180 degree, 300. So you have to, from this 60 degree, okay, this is the point. 60 degree means you have to make your protector over here, right? Protector over here, and you have to mark 60 degree. Maybe it will be like, it may go like this. And 180 degree, from this point 180 degree is obviously to this way, right? So obviously this way. So this is our 180 degree, and one more point is at 300. 300 means this way, right? So this is the, so these are all the, this is asymptote number 1, ACMP1, and this is asymptote number 2, and this is asymptote number 3. I hope you guys can able to capture me, right? So these were the asymptotes. Now we'll go for rule number 4. So you have to find the breakaway and break-in point, right? So breakaway point exists only when the two poles, if there is a root locus on real axis between two poles, then there is exist a breakaway point, right? So there is a, if there is a root locus on real axis between two poles, then there exists a breakaway point, right? So this is very, very important. Similarly, if there is a root locus on real axis is very important. Real axis between two zero, then there exists a break-in point. So breakaway means, breakaway exists only between two poles on the real axis. Similarly, break-in exists only between two zeros on the real axis, right? If there is a root locus lies on real axis between pole and 0, then there may be or may not be breakaway point, right? So this is what the procedure. And if you want to find the breakaway point, what you will do is that from the given open loop transfer function, you have to find out the closed loop characteristic equation. After that, you have to find the value of k. From k, you have to find out differentiation of k with respect to s. That value you have to equate to 0, and you can find out the breakaway point at which the k value is positive. So this is the procedure. But for this problem, unfortunately or fortunately, here for this problem, is there two poles at the real axis? Yes. So we have to check it out, right? So here there are three asymptotes, right? So the step number 4 is to find the breakaway point, right? So to find breakaway point, right? Right. So because there are poles are there, right? So multiple poles are there. So you have to find out the breakaway point, right? So as of now, we found the asymptotes only, right? So you know how to find out breakaway point, right? So first you have to find out a closed loop transfer function for finding breakaway point. That is g of s divided by 1 plus g of s into h of s. But you guys know that if you want to find out a closed loop transfer function from the open loop transfer function, I have told you one shortcut method, right? So closed loop transfer function c of s divided by r of s, that is whatever the value is there, that is the value is k divided by s into s square plus 4s plus 13, right? So this is our open loop transfer function. If you want to write out closed loop transfer function, whatever the value is available in the numerator, just you have to add it at the denominator. So this is how we can find out the closed loop transfer function. If you want, you can check it out, right? So down, the next step is to find out the characteristics equation, right? So here, what is the characteristics equation? Making a denominator polynomial equal to 0 is the characteristic equation. So what is the denominator polynomial? The value is what? S into s square plus 4s plus 13 plus k equal to 0, right? So now tell me what is the value of k? Very simple. K equal to minus of s into s square plus 4s plus 13, right? So this is what the value of k, right? I hope you could understand, right? So k. So now minus s into s square is s cube. S into 4s is 4s square. So 4s square 13 into s is 13s. So this is what the value of k. Now, if you want to find out the break-in point or breakaway point, what you'll do? You will do the differentiation of k with respect to s, and you have to equate to 0. We know the what is the value of k here, right? So k is this one. So now I will find out what is the differentiation. What is the differentiation of minus s cube? So minus, what is the s cube? S cube is 3s square. And 4s square, what is the differentiation? That is 8s. And what is the differentiation of 13s? That is 13. So this is the equation. Now, using this equation, try to find out the roots of s, right? So the roots of s may be the value of s equal to minus 1.33 plus or minus j 1.6. So this is what the root, right? So this is the breakaway point, right? So now what I have to do is that using this breakaway point, using minus 1.33 plus or minus j 1.6, right? So minus 1.33 plus or minus j 1.66, right? So now what I have to do is that you try to substitute the value of s, you try to substitute this value of s over the equation of k, over the equation of k, and if k is positive, then if k is positive, then that point that point may consider as the breakaway point, right? That point may be considered as the breakaway point, right? Consider as breakaway point, right? But in this particular problem, if I am substituting s equal to minus 1.33 plus j 1.66, right? So we have two values, s equal to minus 1.33 plus j 1.66 is the one point. If I am equating that value, we are not getting k is positive, we will be getting k is negative. Similarly, not only that point, we have one more point. That value is equal to minus 1.33 minus j 1.6. Even if you are if you are substituting that points over this k equation, again you will be getting k is negative. Right? So for both the values of k is not positive, right? It is not positive and it is not a real number, right? So that means the value of k is not existing, right? So that means these points are not an actual breakaway points, right? So since the k value is negative, so these values may not lie on the real axis. Obvious, right? So if it is a complex pole, obviously it may not lie on the real axis, right? So therefore, this has neither breakaway point nor break-in point. This system, this closed loop transfer function has neither breakaway point. It has neither breakaway point nor break-in point. So this is the step number 4. Right? So this is very 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 important, right? I hope you now we can understand, right? So next we will try to find out the next step. So this is the breakaway point, right? Here itself we can easily verify. See here, if when there is when there are two poles are exist on the real axis only, this breakaway point may be calculated. That is what, right? But here unfortunately for our problem, here you can look at, there is only one pole is lying at the real axis, unfortunately, right? But obviously from that itself we can tell that there is no breakaway point or break-in point, right? So that is also the clue, right? Anyway, after finding the values also, we may conclude it there is no breakaway point, right? So what is the next one? The next rule is to find if there is a complex pole. If there is, this is very very important. If there is a complex pole, then you have to determine the angle of departure from the complex pole. And if there is a complex zero, then the word is modified to angle of arrival. So there is a formula for angle of departure and angle of arrival, right? So angle of departure from a complex pole A, if there is one pole means, then you have to use the formula 180 degree minus sum of angular vector to that particular pole from the remaining poles plus sum of angular vectors to the complex pole A from the remaining zero. So this is what the formula, right? Here the complex pole is only available, complex zero is not available, so we can go for this particular formula, right? So now we will find out step number 5 is complex pole is there, so we have to ensure or we have to find out the angle of departure. So we have to find out the angle of departure. Right? So for finding angle of departure, what you'll do usually, that is very easy, right? So angle of departure, this one, right? So this is a complex pole, right? So with respect to the complex pole, this is our complex pole. For this pole, you have to draw a line, right? So you have to draw a straight line like this. Okay, let me change the color. Okay, right. So for this one, wherever the pole is there, you have to draw a line, right? So this way, this is one pole, this is one pole, and this is another pole, right? So you have to find out the angle. That is what our objective, right? So now I am going to find out angle of departure from the complex pole P2, right? So that is what I am going to do, right? With respect to the pole 1, so how much? This is pole 1 and this is pole 2. So now using our protector, right? Using our protector, what you have to do is that we have to find out what is the angle, right? So this is our, right? So P1, so we are connecting P1 and P2 with some line, and P2 and P3 is some line, right? So now you have to take your protector like this, right? And you have to keep your protector on P1. From P1 you have to mark what is the angle with P2, right? So from this we can see that the angle will be, say, I can draw some line on it. So from this is P1, right? So I'm keeping it. So now what is the angle between this and this pole and this one? So, right? So this is nothing but our the angle from the pole 1 to complex pole is what? Somewhat around, the angle will be somewhat around 125 degree, right? 125 degree. And similarly, right? So 120 degree, right? Similarly, P3, from P3 you have to keep your protector over here, and P2, what is the angle? P3 and P2 is lying on the real axis, right? So now the angle will be like pi 1 and this is pi 2, right? So this pi 1 and pi 2, both the values you have to add it up, and you have to put 180 degree in front, and you have to subtract it in order to find the angle of departure. So this was the formula, right? So now here 180 degree is there, and pi 1, what is pi 1? From this one to this one is pi 1. So you know what is the angle is, right? So when you are keeping your protector over here, so from this the angle could be, from P1 to P2 the angle could be is 125 degree, and this one plus here pi 2 is the angle between P3 and P2, so the angle is 90 degree. So if I am adding both this thing and I am putting, the answer could be angle of departure is minus 35 degree, right? At angle of departure at the pole, which one? P2, the angle will be minus 35 degree. Similarly, can anyone do the guesses of what is the angle of departure at the pole P3? Any guesses? Yes, obvious, right? So here, whatever pole is there, P1 and P2, right? So the same, but it is at the P3 is at the opposite side, right? So there is complex conjugate. So the answer could be what? Instead of getting minus 35 degree, obviously you'll be getting plus 35 degree, right? Obvious. Why? Because is that P1 and P3. If you are finding the angle between P1 and P3, what you'll do? You will keep your P1 from here to here. You will be calculating the angle. P2 and P3 is both at the 90 degree, so there is no change in it. And if you are calculating, the answer could be 180 degree minus of minus 125 plus 90. So obviously you'll be getting, the answer could be plus 35 degree, right? So this is what the answer, right? So now we have to mark those angle, right? So now I'm marking those, right? So now from this, so now this is the angle, right? So now what you have to do is that from this, so now let me erase that this one, right? So that I can move it, and I can move it. So now I can move it because that is not necessary for the calculation purpose. I should, right? So now let me connect it. I hope you guys have understood, right? So now you have to mark the angle of departure, right? So angle of departure means from this point you have to mark the root locus, right? From this point, angle of departure means minus 130. So from this you have to take your protector, right? So wait a minute. Right. Okay, so take your protector and you have to rotate it, right? So take your protector and wait a minute, right? So you have to see this and all, you have to do it in your notebook also, right? So now I am going to rotate it. going to rotate, right? Okay. So now you have to take your protector like this, and you have to keep your origin at P2, and you have to mark the angle called which one? Which angle you have to mark? You have to mark the angle called minus 35 degree, right? So from this you have to mark minus 35. So will that point will be over here, right? So now you have to mark the point like this, right? So now point could be, so now I am arranging this. I think this and all is not necessary for sake of right. So minus 33, right? So minus 33 is the point, right? So minus 33 means this is the point, right? So minus 33. So from this point we are marking the minus 33 point will be like this, right? So this is going right. So this is minus 33 points, right? After that, finding minus 33.77, right? So you have to find out where that angular departure may lie at the imaginary axis, right? So it may touch it over here, or it may touch over here, or it may touch over here, right? So we have to find out the exact location where that angle of departure intersects with the real axis. Why? Because always the root locus will be parallel to your asymptotes. So that is what, right? So for that, we will go for the next step. That is what you can see that. Find the point where the root locus may be crossing the imaginary axis. You can find using the three method by Routh-Kirchhoff, by trial and error, or you have to put s equal to j omega in the character equation and separate the real and imaginary part. But I will go for the Routh-Kirchhoff because that is the easiest one, right? So now after finding the angle of departure, we know that angle of departure, that is angle of pi a, right? Angle of departure is minus 35 degree, and one more angle pi a equal to plus 35 degree. So both the thing I have found out, right? So that is step number 5. So what is step number 6? Is to find the crossing point of imaginary axis, right? So crossing point on imaginary axis. Right. So for that, we are going to create a Routh table. For finding Routh table, you have to consider the characters equation, right? So here the characters equation is this one, right? So that one I am considering, right? So this is the character equation. After this, using the character equation, try to frame expand it, right? So s into s square is x cube plus 4 into s is 4s square plus 13 into s is 13s plus k equal to 0. This is our character equation. If it is character equation, then how do you form a Routh table? I hope you guys know it, right? So now if you want to form the Routh table, you have to write down a cube s square and s power 1, and this is s power 0. Now after this you have to put a division like symbol, and you will fill the value 1. So the first value is 1, the second value is 4, the third value is 13, fourth value is k. Zigzag pattern I have written. Now if you want to find out this one, what is the value? 13 into 4, right? So what is the value of 13 into 4? 13, so 13 4 are 52 minus k divided by 4. So that here the value could be 0. What about this one? You can multiply this by this minus this into this and divided by this. The answer could be k, right? So now out of this, we have to find out at which place the system should be marginally stable. When the system is marginally stable, when the system is marginally stable, when you are having the concept of ROEZ, right? So when you are having the concept of ROEZ, what is the meaning of ROEZ? That is nothing but row of zero. When the row of, at which place row of zero will always existing odd power s or even power s? It's obviously odd power s, right? So odd power f's, the row of zero may exist. So here which place may exist? 52 minus k divided by 4, right? So at this place 52 minus k divided by 4, that could be 0. And what is the value of k? So 52 minus k equal to 0. And what is the value of k? K could be 52. So this is the value of k. Now after finding the value of k, now I have to find out the location of the roots, right? So I want to find out the location of the root. That is very easy, right? So location of the root. So if you want to find out what is the location, what is the equation you will use? Usually you will use what? Auxiliary equation. So what is the auxiliary equation here? Auxiliary equation is the one which is above the ROH, row of 0. That is 4 into s square plus k into s power 0. That is 4 into s square plus k into s power 0 equal to 0, right? So that is 4s square plus k equal to 0. Here we know that what is the value of k for this marginally stable, that is 52. So 4s square plus 52 equal to 0. 4s square equal to minus 52. What is s square? S square equal to minus 13, and s equal to plus or minus square root of minus 13. So s equal to plus or minus j 3.6. So this is the final answer. So this is the value of s, right? So now our root locus may cross at s equal to plus j 3.6 or minus j 3.6, right? So this is what. So you can see that this after this particular point we have a 3, maybe the value could be 4 over here, so 3.6 may be like this, right? So here this root locus minus 33.7, after that it may go like this and it will cross at 3.6, that is what, plus j 3 point. Similarly, here also some angle of departure is there, right? Angle of departure. What is angle of departure? The value could be plus 35. What will do for that? That is also very easy, no? You have to keep your protector over here. Don't need to keep your protector over here because there is, we can rotate the protector, right? So because here it is not. So now I can rotate it, right? So I am rotating it, right? So from this you have to find out what is the angle 33.3, right? Obviously at this place, right? So now at this place let me make a mark on it at this place. So this is the place, right? So at this place I am going to give some mark on it. So this is the place. So now, right? So now I can give the notation. So from here to here the angle will be plus 35 degree. Similarly, this will also be like this, right? After it reaches certain point, it should be parallel to your asymptotes, right? So at which point it is intersecting, obviously we know, right? So from that is also I have told you, right? So that is nothing but the crossing point. Now tell me what is the crossing point? If it is here 3.6 means the opposite value is minus j 3.6. So the value could be around over here because this could be minus 4. So where the root locus will be? It will be it will be like this, it will be like this one, right? So this is our root locus. So root locus, this is our root locus, and this is our another root locus, and this is the last root locus. So this is how we will find out the root locus method, right? So it is completed, right? So with that, this is over, right? That this is over. So now at k value is 52. At k value 52 only we are getting the crossover point, right? So this is how we have to find it. So now whatever I have shown you, the same thing I have put it in the graph. That's it, right? So you can see that this is our crossing point minus 1.33, and this is our pole P2, and this is our pole P1, and this is our pole P3. So whatever I have simply marked it in the normal plane S plane, the same thing that people have marked with the graph sheet, right? So you can do like this also. So you can see that this is our one root locus, and this is the another root locus, right? And this is the one more root locus. Asymptote and root locus both are same, right? For this root locus problem, right? This is how.